In this case here, we have participants who were patients with persistent shoulder pain. We have here an experiment because they are randomly assigned to either shoulder surgery or the sham surgery. You're under anesthesia anyway, and it looks like you've had surgery, but you've just had skin incisions. And we have a quantitative variable, which was the shoulder score on a typical medical score here, with values that range from 0 to 48, where 48 is the best score, a year after the study. Now, when we were covering data collection studies, a lot of students sometimes thought that if you're going to collect data over a long time, like a whole year, that it must be some kind of cohort. No, not necessarily, right? Some things don't get better right away. So the fact that it takes a whole year to figure out how people are doing, that's just what you want to study. What your end goal is to make sure people are better after that much time. All right, so because the individuals here were randomly assigned to those two conditions, that means that we have two independent random samples, and we have, again, a quantitative variable. And you're asked to obtain a confidence interval for the mean difference in shoulder condition score 1 year after intervention in the entire population of patients with persistent shoulder pain. So that means you're asked for a 95% confidence interval for mu shoulder surgery minus mu sham. Again, if you want to use, for example, Crunchit or same thing with a TI calculator, you would have to provide information about the sample size n, the sample mean x bar, and the sample standard deviation s. Okay, so you can ignore these values here for Crunchit and TI calculator. There are some software that tell you which of those two do you have, which one do you want to enter. I used a different software here, Minitab, and it gives me the confidence interval as negative 1.9 to positive 4.5. What is our interpretation? We are 95% confident that the mean difference in shoulder condition score 1 year after such interventions in the population of patients with persistent shoulder pain is one value inside this range. So it could be as low as negative 1.9, or it could be as high as positive 4.5. So the important thing here is that our 95% confidence interval for this is negative 1.9 to positive 4.5. And so therefore, we think that this difference between those two population parameters is somewhere in there. And so what does that tell us? That tells us that mu1 minus mu2 could be a negative value, which means that the shoulder score in this population, the mean shoulder score in this population that gets the fake treatment could be higher than the mean shoulder score for those who get the real surgery. So not a good outcome. Or on the positive side, it could be that the mean shoulder score in the population of patients who get the real shoulder surgery is higher than for the population who gets the fake surgery. Or 0 is also a possibility. It could be that it makes no difference in those two populations on average. The difference in those two means is 0, and so no difference. Which is why the conclusion is that the findings are inconclusive. It could go either way. And in fact, when you look at that p-value for, based on the same data, if you have a null hypothesis that I'll call that mu1 minus mu2 equals 0 versus an alternative that mu1 minus mu2 is not equal to 0 in this case, that's two-sided, and we get a p-value of 42%. All right, so here what we're saying is if the two population means were the same, we would very easily get results at least as extreme as the ones that were observed in this experiment, and therefore the findings are inconclusive. The null hypothesis could very well be true, or either way, people could be better off on average with the fake surgery, or they could be better off on average with the real surgery. Now, this is where you see that the confidence interval is a little bit more informative anyway than just the p-value, because the p-value would tell us we failed to find evidence of an effect on average of surgery versus sham on shoulder condition score in the population of patients with persistent shoulder pain. But the confidence interval tells you that either way, if you're better off with the fake surgery, it's by roughly a -2 on a scale of 0 to 48, so that's not a whole lot. Or if the other one is better, then you're better off by 4.5 out of a scale of 48, so that's up to 10% better. That's, I mean, on a scale of 0 to 48, those are not going to be huge differences anyway. Not only the findings are inconclusive, but also they're not looking very good. It's not like, oh, potentially one of them could be a drastic improvement. No.